Dhanamajuri Community College ki Media Division ne puthokpa khogi online classes video uploading aduga Zoom meeting ne chingba meeting tabiraba mayam butaram no okse ngasi si akhoi series of khogi lectures which are uploaded in the YouTube channels ta khoina upload tawjariba Dhanamajuri University ki makhada laiba DM College of Science ki PG Department of Mathematics ki MSc ki students singi damakta mahakna lecture ma pibigani Moirang Them Dr. Moirang Them Kuber Singh. He is the associate professor in the PG Department of Mathematics, Dhanamajuri University. So he will talk on the topic solution of the linear programming problems by simplex method. This is in one of the topics in the syllabus and the curriculum of the MSc students for mathematics.
The linear programming problem by simplex method. So this topic is also part of the PG syllabus, second and fourth semester. So the linear programming problem LPP is one of the most important topics in the operation research. Simplex method is a very powerful algorithm for solving LPP problems. Actually, in the optimization theory, this algorithm is created by mathematician George Danzig in 1947. It is a very popular algorithm. So today's lecture is solution of LPP by simplex method. At the end of today's topic, so you will be able to understand standard form of the LPP from the given hypothesis. Then next you try to understand method of solving LPP, then analyze and observe the optimal feasible solution. So what is the standard form of LPP? So we have to convert the constraints into equations by using, say, slack variable or surplus variable wherever we need it. Then the right hand side of the constraint equation should be non-negative. All variables should be non-negative. Then objective function is of the maximization type. In the LPP problem, the objective function may be maximization or minimization. If it is given in the minimization form, then we have to convert it into maximization. Then the constant in equation may be less than or greater than. So first we have to put in the standard form. So let us discuss today how to solve the problem. So here the objective function is maximize z x1 plus 9x2 plus x3, then subject to the constraint. So there are two constraints and the objective function is in the form of maximization. So this is in the standard form. Then the two constraints is less than or equal to. So now we have to convert them into equation by using slack variables. We have to put some variable on the left hand side. This variable is known as slack variable. If the in equation is greater than or equal to type, then we have to subtract something from left hand side. Then the variable is called surplus variable. Here we have to introduce two slack variable, and the right hand members are all non-negative. This is in the standard form. So let us see how to solve this problem. So first we have to introduce two slack variables. By introducing two slack variables, say S1 and S2, we may write the problem: maximize z x1 plus 9x2 plus x3 plus 0 into S1 plus 0 into S2. The coefficient of the variable slack variable will be 0. subject to say x1 plus 2x2 plus 3x3, then we have to put s1, then 0 into s2 equal to 9, then 3x1 plus 2x2 plus 2x3, say plus 0 into s1, then s2 equal to 15. Then this is x1 comma x2 x3 s1 s2 greater than equal to 0. So this is the standard form of the problem. Then next we have to do iteration. So first initial table for iteration is then this is x1 x2 x3 s1 s2, then last one is right ratio. Then you have to fill up this table. So the coefficient of x1 is 1, 9, you write 1. This coefficient is from the objective function. You take 191, then 0, 0. Then second, you have to fill up here. This is the first, you take coefficient from first equation, 1, 2, 3, 1, 0. Then from second equation, 3, 2, 2, 0, 1. Then you write the right hand member here, 9, 15. Then you write the variable. So last you write here jj minus cj. So you take the initial basic variable is s1, s2. This s1 and s2, these two column vector represent a unit matrix. So you see the unit matrix and take the variable as initial basic variable. Then coefficient of s1 s2 is 0, 0, you put here. So this is the coefficient of the basic variable. This is the basic variable. This is the basic solution. So you have to fill up all this table. Then next, you find out the value of jj minus cj. What is jj minus cj? So you multiply 0 here, here. So it will become 0. Then you multiply cb and the columns of the x1. So this is jj, cj. Cj is a coefficient of the variable in the objective function. So you multiply here 0, then subtract 1, minus 1, 0, 0, then 0, 0 minus 9, then 0 you multiply here, then subtract minus 1, 0, 0, 0, then 0. Then the value of jj minus cj, if all these are positive, then our iteration is over. But here is the negative, so we have to go to next iteration. For this, you have to select the most negative one. So you select this is most negative column. So this is the pivot column. Then next, you divide this basic solution by this value, and here is 15. Then you divide, this is 2. So this is 4.5, this is 7.5. Then you take the minimum one. Minimum is this. So this is the pivot row. Here is pivot column, here is pivot row. So this is the pivot element. This is the pivot element. Then next, you go second table. Then you can continue this table also for time saving. or you make another table also, this. So now we have to change this basic variable s1 by x2. x2 here, this is s2. Then you write, you change this 2 is 1, this 2 is 0. This is the 2 is changed by 1, this is 0. How to change this 1? So you may divide this row by this element. So it become 9 by 2, it become 1 by 2, then this is 3 by 2, this is 1 by 2, this is 0. Then for converting this 0, we can subtract second row by first row. You write here second row by first row. So you subtract here, it becomes 6, then it becomes 2, this is minus 1, this is minus 1, this is 1. And coefficient of x2 is 9, s2 is 0. Again you find out jj minus cj, is done earlier. So you multiply here it1 by 2. Then 0, this is 9 by 2. 9 by 2 minus 1, 7 by 2. Then this is 0, this is 9, 9 by 9, 0, 0, this is 27 by 2, minus 1, 25 by 2. Then this is 0, this is 9 by 2. Then this is 0, this is 0, 0. So now the value of jj minus cz is all are positive. So if jj minus cz all are positive, then your optimum stays, since all jj minus cj are get equal to 0. So an optimum solution has been obtained. Maximize z equal to it1 by 2. There is no x1, so you write x1 is 0, here is x2, this is 9 by 2, and you will not take the value s2. s2 is a select variable. So this is the optimum solution. Optimum solution means the best solution. We have to find out the best solution. So maximize z equal to it1 by 2, x1 is 0, x2, you write x3 equal to 0. So this is the method for solving LPP problem. So you try to understand this problem, then if you know this solution, then you can try one problem. So you try this problem and try to find out the optimum solution. Thank you.